Today we're looking at quadratic equations and how to solve them using the quadratic formula, one of the most powerful tools in algebra. Here's our quadratic equation. 2x squared plus 3x minus 5 equals 0. This is a typical quadratic equation that we can't easily solve by factoring. Our goal is to find the values of x that make this equation true. These values are called the roots or solutions of the equation, and they represent the x-coordinates where the parabola crosses the x-axis when graphed. The quadratic formula works with the standard form of a quadratic equation, ax squared plus bx plus c equals 0. To use the formula, we first need to identify the coefficients a, b, and c from our equation. Looking at our equation, we can see that the coefficient of x squared is 2, so a equals 2. The coefficient of x is 3, so b equals 3. And our constant term is negative 5, so c equals negative 5. Let's highlight these coefficients in our original equation. The blue 2 is our coefficient a, the green 3 is our coefficient b, and the red negative 5 is our coefficient c. And here's how they correspond to the variables in our standard form. These coefficients are what we'll plug into the quadratic formula to find our solution. In the next step, we'll substitute these values into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This will give us the exact solutions to our equation. With a equals 2, b equals 3, and c equals negative 5, we're now ready to calculate the solutions using the quadratic formula. Today we'll solve a quadratic equation using the quadratic formula. When we have an equation in the form ax squared plus bx plus c equals 0, the quadratic formula gives us a direct way to find the solutions. Before we can apply the formula, we need to identify the three coefficients in our quadratic equation. These are labeled a, b, and c in the standard form. Looking at our equation, we can see that the coefficient a is 2. This is the number in front of x squared, representing the quadratic term. The value of a tells us about the shape of the parabola. Since a is positive, the parabola opens upward. Next, the coefficient b is 3, which appears in front of x. This is the linear term in our equation. The value of b influences where the parabola crosses the y-axis and affects the axis of symmetry. Finally, the constant term c equals negative 5. This is the term without any variable. The value of c determines where the parabola crosses the y-axis, specifically at the point 0, negative 5. With all three coefficients identified, we're ready to apply the quadratic formula. This powerful formula works for any quadratic equation and gives us the exact solutions without having to factor or complete the square. The quadratic formula states that for an equation in the form ax squared plus bx plus c equals 0, the solutions are x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's break down what this formula means. The plus or minus symbol tells us there are typically two solutions to a quadratic equation. The expression under the square root, b squared minus 4ac, is called the discriminant. It determines how many real solutions our equation has, two distinct solutions if positive, one solution if 0, or no real solutions if negative. For our equation 2x squared plus 3x minus 5 equals 0, we'll substitute a equals 2, b equals 3, and c equals negative 5 into this formula. This will give us the x values that make the original equation equal to 0, which are the points where the parabola crosses the x-axis. We now have everything we need to calculate the solutions. The quadratic formula is especially useful when an equation can't be easily factored, giving us a reliable method to find the exact solutions for any quadratic equation. Now we've reached the part where we need to calculate the discriminant in our quadratic formula. The discriminant is the expression under the square root, which in this case is 49. We need to simplify the square root of 49. Since 7 times 7 equals 49, the square root of 49 is 7. This is an important step because working with the actual number rather than the square root makes our calculations much simpler. Now we can substitute 7 for the square root of 49 in our original equation. This gives us x equals -3 plus or minus 7, all divided by 4. This simplified form makes it much easier to calculate our final answers. The plus-minus symbol indicates that we actually have two different solutions to our quadratic equation. This is because quadratic equations typically have two solutions, one when we use the plus sign and another when we use the minus sign. Let's split this into our two separate equations. For the first solution, we replace the plus-minus symbol with just the plus sign. This gives us x equals -3 plus 7, all divided by 4. This will give us our first root. For the second solution, we use the minus sign instead. This gives us x equals -3 minus 7, all divided by 4. This calculation will lead us to our second root. Notice how the plus-minus symbol in the quadratic formula efficiently represents both solutions. Both of these expressions can be simplified further by performing the addition and subtraction in the numerators. In the next steps, we'll calculate the exact values for each of our solutions. By taking the square root of the discriminant, we've made significant progress. We've transformed our original quadratic formula into two simpler linear expressions that we can now solve separately. Now that we have our quadratic formula set up, we can find the solutions to our equation. The plus-minus symbol tells us we'll actually have two different solutions to calculate. Let's find the first solution by focusing on the plus sign in our formula. I'll highlight this plus sign in yellow to show that we're using the positive case of the quadratic formula. Our first step is to calculate what's happening in the numerator. We need to add -3 and +7. When we combine these values, -3 plus 7 equals +4. Now we can substitute this value of 4 back into our equation. This gives us x equals 4 divided by 4. For the final step, we need to perform the division. Any number divided by itself equals 1, so 4 divided by 4 equals 1. Therefore, x equals 1 is our first solution to the original quadratic equation. This is what we call a root or 0 of the equation, a value that makes the original equation equal to 0. Let's highlight this first solution. We found that x equals 1 by taking the positive case of the quadratic formula and following through with the calculation step by step. So to summarize, we've used the quadratic formula with the plus sign to find that x equals 1 is one of our solutions. This methodical approach of working through the formula step by step helps us avoid calculation errors.